This question is on static electricity, and the basic unit will be your law of electrostatic, where like charges will repel and unlike charges will attract. All right, so you're given object 1 is given a negative charge and is placed on the balance. So let's assume a nice number here. There are excess 5 electrons, making this object 1 negatively charged, and for object 2 it is also charged and is blocked close to object 1, and the reading balance changes as shown. So you can see that from 93.5 it decreases to 92.9 gram. That means to say object 1 seems to become lighter. All right, that means to say there's something like pulling it up. So you should know that there's actually a attraction force. So since object 1 is negative, that means to say object 2 has to be positive. To make things easy, let's assume it has excess 5 protons, making it positively charged. And you should know that electric force is an action reaction, so it comes in a pair, so they are both attracting each other. But for object 1, since it's being attracted up, it's lighter on the balance, therefore the reading decrease. All right, so for the question asks which action would further decrease the reading on the balance. You want the reading to be further reduced. That means to say you want the attraction force on the object 1 to be greater. Now to help you visualize, maybe I can redraw it like the object 2 is a +5 and the bottom object 1 will be a -5. So since it's a unlike, both of them have unlike charges, it's an attraction force. So if I were to use another analogy, it's like two forces pulling the box. Both are 5 Newton, the resultant will be 10 Newton. So for this case, you can treat it as the attraction force between the object 1 and 2 will be like 10 units. All right. So let's look at option number 1, and you're going to add the same number of electrons. Option 2 is removed. To make things easy, let's talk about adding 3 electrons to both object 1 and 2. Okay, so that means to say for option A, all right, if you add 3 electrons to the object 1, that will become -8. All right, and the top here, since you added 3 more electrons, that will be just a +2. So it is still unlike charges. There will still be attraction force between the two. And so if you have to use the dynamics kind of analogy, so that means to say, if you to look at it this way, so this is a 2 Newton to the right, and that will be a 8 Newton to the right. The total resultant force will be 10 also. So the attraction force between both of them will be 10 units. It will be the same. That means to say the reading on the balance will still be 92.9 gram. Next, let's go to option B, where you remove, let's put it a number, let's remove 3 electrons from both. So if that's the case, the object 2 will be a +8, and then the bottom will be a -2. So once again, that will be a attraction force. All right, so it's the same thing. It's like the box here is a 8 Newton and a 2 Newton, like similar to option 1. So the total attraction force, which is an action reaction pair, and they are always equal and opposite, it will still be 10 Newton. So the reading will still be the same. Next, for option C, you're going to transfer electrons from object 1 to object 2. Let's assume 3 electrons. So if you're going to take 3 electrons from here and transfer it to this side here, so basically your object 1 will only left with excess 2 electrons, so that will be a -2. And then you take the electrons and go into object 2, a bit of neutralization, so the object 2 will now be just excess 2 protons. So it's the same thing, it's an attraction. You can think as a box, 2 Newton, 2 Newton, and now the resultant force will be 4 Newton. All right, so it's like 4 units. And the attraction force is actually lesser, so the reading will actually increase instead of decrease. So C will be wrong. Let's look at the last option where you're going to transfer electrons from object 2 to object 1 instead. So same thing, I'm going to treat it as 3 electrons. So I'll just draw it here, there's some space here. So from object 2, you're going to remove electrons, so this will make it further more positive charge. So there will be a +8 here, and then transfer down to object 1. So basically that will be a -8. All right, total there will be -8. So you can look at it using your forces. It's like 8 both in the same direction. Total will be 16 Newton. The traction force therefore is 16 units. It's the strongest. If it's strongest, object 1 will be lifted further up, the reading will decrease. Therefore D will be the answer. All right, thank you.